So, hello Internet. So this video is a little different because I'm now with Anna, who's also a PhD student here at the University of Calgary, if I have not mentioned that to you guys before. So yeah, Anna, what do you do as a PhD student?
Yeah, so as Pan said, I'm a PhD student just entering my 4th year of my program. I'm studying the magnetic field of the Milky Way galaxy using radio astronomy. So kind of physics, but also connected to astronomy.
Oh wow, yeah. So basically, Anna is another area of physics entirely because I do quantum information and quantum control. So most of the math we do are never overlaps, I don't think.
Yeah, probably not. Probably pretty different, and the scales of the things that we study are also.
Yeah, that's true. I do the little stuff. She does the huge stuff, as you know, Trump liked to say.
Something like that, yeah.
Yeah, but one thing we definitely did here as PhD students are we also teach undergrads, students. And of course we're physicists, so we have been learning this for quite some time.
Yeah. So we're kind of lifelong students of physics, I guess.
Essentially. And trust us, it's still hard every day.
Yeah, it's always a challenge, but that's sort of the fun part of it, I think, for us as well, like is overcoming those challenges. So,
yeah. So maybe Anna, can you tell us like how you got into physics in the first place?
Yeah, so it was sort of almost by accident in a way. I didn't really know growing up. I didn't really know what I wanted to be when I grew up, kind of thing. So I just really enjoyed math and physics in high school and did really well in those courses. And so I figured, well, let's try and do an undergrad in physics, and that went okay. And then went on to grad school, and here we are. So.
Yay! Because actually my story is pretty similar as well.
Okay.
I actually failed physics during the 10th grade and 11th grade, and I only ever got into physics, kind of get it a little bit in the 12th grade and kind of be able to pass. So I used to say I fall into physics accidentally, because I was looking for an undergrad scholarship, because everybody knows college are expensive.
Yeah.
And I got a grade that's okay enough to get into science.
Nice.
And I chose physics because not a lot of people chose it. And it turned out I actually really liked it. And I still like it. So
yeah, for sure. Like, I mean, we've both been in this for like 10-ish years now, just like post-secondary. So you have to like it for sure to continue on with it. So obviously we've both grown to like physics a lot, for sure.
Yeah. But we also teach students who are engineering backgrounds, who are not in physics background. So there's also the end of the other of the spectrum of how much you like physics, which is, oh boy, this is so hard.
Yeah, and a lot of first-year students come to it with that sort of attitude, of saying that they're kind of afraid of it in a way, because it's been known to be a difficult subject.
Yeah. And so I guess that's a long introduction to say that today we kind of want to talk a little bit about what we see as, the problem we commonly see in students and in ourselves when we're learning physics, and how you can get over that, or at least survive your physics class as you go along in your
and hopefully have
life.
Some fun learning it too. So not just getting through, but
the fun of learning things I think is essential.
Yeah, for sure.
Yeah. Okay. So Anna, what do you think is like the most common problem in the students?
Well, so if sort of starting with this idea of looking at students who are coming into learning physics without necessarily being interested in it to begin with. So not the students who are saying, oh, I want to, this is what I want to study, and I know I want to be able to learn this, but maybe students who just need this program requirement for something else that they might be studying, whether it's engineering or biology or getting into med school, things like this. And so like we mentioned, a lot of students do come into it with a bit of a fear and an uncertainty surrounding that. And so I think that's one thing to overcome, and also a bit feeling maybe disconnected from physics in the real world kind of sense.
Yeah, so the way I was taught physics was that this is the topic, like in high school at least, like this is the topic, this is the formula, plug in all the numbers, essentially. So yeah, I can kind of see that, like, one reason that why I failed physics before is because I see the formula, I don't understand what it means at all. I don't connect that to the real world. There's no connection to that.
Yeah, and also a connection to the real world in the sense of, you know, if you mention to someone that you're studying biology, they might sort of immediately ask you, like, oh, like, are you thinking of becoming a doctor or something similar? Because everyone's met medical doctors before. We know, kind of have an idea of what they do. We know that they typically have some kind of biology background. Whereas with physicists, a lot of the work that physicists do is a little bit behind the scenes in a way. It's not as evident publicly what we do.
Basically, we make models so that engineers can use it.
Yeah, so that engineers can build stuff and make technological advancements. We do a lot of the fundamental work for that, but it is a bit behind the scenes.
Yeah, and I guess the fear was kind of, like, it's kind of the fear of the unknown almost. Would you think? So.
Yeah, a little bit. It's a fear of things that are very abstract and hard to pin down.
Yeah, and that at least in my experience leads to a lot of students freaking out before they even really have a good look at the topic or at the problem. They already come with an attitude that this is so hard, this is so difficult, I don't like it. Yeah. And when you come with that kind of wall, it's difficult to learn in general. Yeah.
And it's also, I mean, obviously physics is very strongly connected to mathematics. So students who have found that they've struggled with math in the past also sometimes tend to have a lot of apprehensions because they don't quite see how to. The key is to be able to sort of accept math as a language that's necessary to communicate and to study physics. And so if you're kind of missing that link, that can be a real challenge as well.
Yeah. And actually, I kind of mentioned this to Anna before when we were planning the video, that was the problem that I have. That's one reason why I failed, is that with the formula, not only I don't understand how that's connected to reality, I don't understand what it means. So I can't even understand the context of using them. And as you know, if you go into like a high school exam or an undergrad exam, you're taught like 30 formulas in a semester, and it's like if you have no idea how to use it, then of course the grade is gonna.
Yeah, and even if you come to the point where you do know how to use it in the sense that you can solve the problems. You were mentioning that you kind of had this approach of solving the problems as puzzles almost, where you take the math, you apply it, you solve the puzzle, you get an answer to the problem, but you might still not have a true understanding of the physics behind it. So that's I think that's another challenge.
Yeah, so math is a
math is important. Yeah, for sure.
Yep. Yeah, but it's not only just like math as well. It's kind of how physics itself is taught in school. Like, it's very dry. You memorize.
It can be
formulas. You do examples or problems, which again sometimes is really manufactured, so it feels disconnected to reality. Like, I've never seen this happen in real life. Why do I care?
Right.
Almost.
Right.
Yeah.
Yeah. Sort of artificial kinds of problems. I hear.
And like coming from this perspective of somebody who has already taught physics, it's like sometimes that's necessary, because if you try to tackle a real world problem, it's just way too hard.
Yeah, so you have to make all kinds of simplifying assumptions that then they turn the problems into something like much more tractable that you can actually solve. But ultimately there is sometimes a disconnect there.
Yeah, that's why the cow has to be spherical.
Yes, the spherical cow is a classic. Yeah, for sure.
And now it's also the reason I think that the way physics are taught in terms of like giving formulas a lot is because there's also a lot of knowledge that we kind of have to try to transfer to the student in a very short time, actually. Like,
Yeah.
I never feel like we have time for the student to sit down and really understand what the formula is trying to say.
Yeah, that's true. And I think part of that is because in terms of the study of physics, we've come such a long way. There is so much knowledge.
Yeah.
There is such a
Yeah.
huge volume of background knowledge that in teaching undergrads, we try to pass all of that on to them in that 4-year span, and it's nearly impossible to.
Yeah, it's like adding math to that as well. It's like
Yeah. So a lot of times just getting through all those, learning all these equations, learning all these physics laws, it gets taught very, very rapidly because there is so much to cover, and so that can be like, it gives you a good idea of what sorts of knowledge is out there and what it is that you need to learn and need to have an awareness of, but at the same time it's hard to have time to delve deep into all of that.
Yeah, so, if you feel like you cannot master physics, that's fine, that's okay. That's what everybody feels.
Yeah. The thing is, you're not going to know all of it after having seen it the first time.
Yeah.
You're constantly going to be relearning things and reassessing and looking at things again until they kind of click. In terms of the instructors who are teaching physics at an undergrad level, the thing is, I think for students to realize is that those instructors or those professors themselves are on some level still in the process of learning themselves too.
Yeah,
right?
that's true.
So the learning never ends. You're always having to revisit things and look at concepts from a different light. And so I think having students realize that it's not like you suddenly become a professor and you then know everything there is to know about physics. Doesn't happen, right?
Yeah, that doesn't happen. Like actually, like, the higher you go, the more specific you become.
True.
Yeah,
Yes.
so you become so niche at some point, and you probably don't, like, I would not understand Anna's work just by
Definitely
looking
don't
at
understand patterns.
Yeah, so it's like
you have to study a lot.
Yeah.
So
So if you feel like you understand classical mechanics but cannot get a hold of thermodynamics, that's fine. That's okay. That's perfectly normal. That's what happens to physicists all the time.
yeah, the more you learn, the more you realize you don't know also, and the more you realize you need to learn more and learn things in different ways as well. To kind of master it. But yeah, with that, I think if in the cases where lectures are being taught very much in a way where there's a professor standing at the front of the room just sort of imparting knowledge to students can very much get the impression that, this is this is the person that knows it all, and they must be super smart and know all of it, and I'm just struggling with this Newton's second law here. How am I ever going to attain that level? And it's not. I don't think it's the right way to think about it.
Definitely not the right way to think about it. And I think this kind of harkens back to when we're saying that we don't have a lot of people who does physics who has a presence in the public sphere, like the people, like the name that people would know would be Einstein, who is obviously really, really good.
Sure.
Also through decades of working on those problems, and Richard Feynman, who has a certain kind of showmanship about him as well.
Yes, exactly.
So you can, so he has that genius projecting out of him all the time. That can be really intimidating. If you think that's the only way to be a physicist, that is not the only way to be a physicist. That's
true. There are so many people contributing to knowledge in physics nowadays on so many different levels in so many different ways, and it's there's not just that one way or that image we have in our minds maybe of what a physicist is. That's not the only way to be contributing, I guess.
Yeah. So I guess we kind of agree that the way physics is taught. There's like things that we need to improve as, you know, people who's now sitting on the other side, essentially.
Yeah, having attempted teaching a little bit ourselves, we might have some ideas about how to.
Yeah, it's going to be hard to balance it out with the kind of like the amount of material that we have to teach, because like I mostly teach in labs where I get a chance to interact directly with the students, and I always found that kind of more personalized interaction seems to work better with the students, because part of physics is kind of getting the way you thinking things straight.
Yeah.
So having
Yeah,
that kind of
that's true.
mentorship is actually, I think it would make the experience at least less painful for a lot of students. Make it more of a two-way conversation than just us going blah 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 blah.
Yeah, I think that's a great point, because if you're having that kind of conversation with students, you can see where they're at in terms of whether they're kind of on the right track in their thought process, and you can work with them that way.
Yeah.
And that's obviously harder to do in a large classroom where.
Exactly.
So I experienced this recently. I got to teach a group of 200 students, and I had to stick to a curriculum. I wasn't designing the course myself, so it was, like you mentioned, there's so much content to get through. I was finding that I was constantly behind on where I was supposed to be, and so I think that's a real challenge, and I think maybe something that professors or sort of institutions in general could start thinking about is there a way to communicate physics in a way that kind of less is more? So
That's true, yeah.
maybe reduce the content that's in a given course a little bit to allow students the time to explore the topics properly.
That's true, and yeah, I do think understand the way to think as a physicist is a little more important than knowing all the formulas.
Yeah.
Essentially, like being able to kind of like look at the equation and understand what that translates into everyday life. Like if the situation changes, how would that change the answer? Would it?
Right, so that you're not just limiting yourself to being able to solve a particular type of problem.
Yeah.
To sort of developing a flexibility to work with those concepts and apply them across different areas.
Yeah.
I think that's important, and I think it's something that really just takes time. It's not something you can learn quickly and say, okay, I've studied this. I've studied, Newton's third law. Now I know it. It's not.
Yeah, that doesn't happen in 10 minutes.
No, exactly. So you need the time to develop that way of thinking that you can apply it to different things.
Yeah, but that's definitely, there's a long way to go to actually kind of put that into a formal teaching and learning kind of environment.
Sure, it
right
is.
Now.
It is. It's a challenge, but I think it's something that people are really starting to think more about, is to allow for a more a learning environment where students can be more actively involved in the learning process, and not just that receiving information, but sort of having a conversation of sorts.
Yeah. I agree. It's like physics is something you really need to learn in an active way rather than a passive way. Like you don't sit down and just listen to lectures and memorize things. You really have to spend time and think about it and put that knowledge to the test, basically, in different situations. And in some ways, the structure of how the physics is taught already tries to do it, but is doing it really badly.
It depends. It varies. People are trying, but it can be a very challenging thing to move away from in this area where there is such a strong kind of traditional way that things are taught, to move into a more flexible kind of learning environment.
So what we mentioned is kind of like involving the teaching side of things, but now if you're a student, you don't really have an options on that, and if you're stuck with really dry lecture and problem solving kind of structure, what do you think they should do?
What students should do? So I think definitely having communication with someone about physics, two-way communication is key. So I think with that, collaborating with friends who are taking the same class, or people who've taken it before, working together with people, kind of like sharing the things that you've learned, maybe things that you're confused about, talking to your friends.
Very
about
important.
Yeah, like tell your friends, like, hey, I totally don't get this. Did you understand when the professor said such and such? And yeah, maybe your friend picked up on that, and you can share those ideas and talk to each other. So I think it's much easier if you work together in a team rather than by yourself all the time.
I totally agree on that. That's basically how I'm able to get through like grad level classes. It's like there's just too much and too difficult for one person to really do by themselves.
Yeah, every grad student is gonna definitely rely on their friends a lot to help them figure things out and support each other in that learning process. Definitely.
Yeah, and it's also kind of good in a way because you have somebody to kind of sanity check you when you're working on problems.
Yes.
Like if you work on a problem by yourself, sometimes you can get into a thinking spiral that you're convincing yourself that something is correct.
Mm-hmm.
And sometimes you can get out of it by kind of reality check with like the things you know. Basically in reality outside of classroom, but that to me only work for like Newtonian mechanics and things like that. Once you go into like electromagnetism, like I have no idea what's going on anymore at that point, and quantum mechanics is just
Yeah, that's an interesting, just to tie in a bit about, we were talking about math earlier, that there are certain areas of physics where doing those kinds of sanity checks is relatively easy. Like if you're saying you're solving a problem and you're getting some ridiculous, say, speed for a car that's traveling down the highway, it's going at 600 kilometers an hour. You say to yourself, well, maybe that doesn't seem right.
Yeah, you would know.
And you check. But the thing is, the further you get in physics, the more difficult it is to do those sanity checks, because the concepts that you come across have actually really surprising results sometimes. And so
exactly. Yeah.
It becomes, I think, kind of tied into that, more important to be talking to other people about it as well, to say, okay, hey, this is what I got. Did you get the same thing? Because I can't tell whether this is a crazy answer or not. You know?
So like totally do that. Like work on problems with other people, because I think assignments is going to be like the only part where you get to do that with your peers essentially.
Yeah. Yeah, that's true. But even like outside, even if you don't have an assignment, do that week. Like still, sit down with your friends, have a coffee, and chat about physics. Like I think it's worth doing, and you learn a lot that way.
Yeah, and also it's like teaching, like trying to articulate what you have learned for somebody else. Like teaching somebody else actually kind of helps you really have to go back and think about what you understand, because the first time you understand, everything's going to be vague and sort of make sense.
Yep.
Until you really check it.
Yep. Or you'll come across those few types of problems that are on the assignments, and you know how to solve them, and you're like, oh yeah, I got all this, I know all of it, but then it's like, wait, no,
nope.
Maybe not.
Nope.
So
nope.
Yeah, definitely having that.
Yeah.
Yeah, teaching someone else a concept definitely really solidifies it, I think, for the person. I mean, you've probably experienced this with TAing as well. Like, you teach a student a topic that you feel like, oh, I've known this for ages. Like it's
totally.
It's easy.
Yeah, this is like first year physics. I've seen this before.
Yeah, but then you teach it to someone else, and you're like, wait a minute, like this is actually really subtle. And
and it's like, and the good part is that a lot of students, when you have a one-on-one conversation with them and have a bit of relationship with them, they'll start asking really, really good and really, really difficult questions.
Yep.
And that's
true.
And part of it, I think, is because they won't ask that normally, because they feel like that has to be a stupid question.
But if they trust you, they're gonna ask.
Yeah. And actually, all of those really simple but subtle questions are what is really interesting, and what kind of forms the understanding, the more deeper understanding of the topic.
I agree.
Yeah. So never think your question is stupid.
Nope.
Ask it.
And if even if you've got friends outside of physics or who aren't taking this course, but you've learned something interesting, you share it with them, try. Maybe they might find it interesting, and you might be able to find a way to explain it that helps them understand it, and in the process helps you understand it better as well. So what do you think about like how should students go about studying generally?
Studying generally?
Generally for physics, that is, so if they've got exams coming up in their courses, things like that.
Yeah, I would say first thing, get a lot of sleep.
Yeah, sure.
I have been through those kind of sleep deprived exams before, and I can tell you with physics it doesn't work. It does not work at all. You're gonna trip on the simplest concept you're not supposed to trip, and everything you were doing would be wrong.
Yeah.
It's like
Even
do not skip on sleep. This is really important.
Stay up all night and study all the difficult stuff, and then mess up on the easy stuff because you're exhausted, right?
Yeah, that's one thing that I feel is different from like studying other things like biology, where you can kind of cram, but physics you cannot cram. Like do not cram.
Yeah, this is like if your professor tells you this on the first day of classes, like don't cram physics, keep up with the work. They're not saying that to be annoying. That is one of the, I would say the number one thing is you can't learn physics quickly or last minute. You have to be you have to be thinking about it over an extended period of time.
Yeah, so spend, even if you don't have an assignment, spend 30 minutes, 15 minutes just thinking about what you've learned each day.
Definitely.
Put in a small amount of work is better than cramming it at the end when it comes to physics. Yeah.
And if you are sort of thinking about it every day, you might find yourself, kind of in a different situation where you're not even directly thinking about physics.
Oh yeah.
But something might just sort of click in your mind because it's been kind of brewing there for a while. Right?
Yeah. And that still happens to me when I read papers actually.
Yeah. It just kind of, it's sort of there, but you do have to like expose yourself to it daily for that sort of thing to happen.
Yeah.
You can't just not look at your physics notes for 3 weeks and then
Do not do that.
hope to have an epiphany of sorts. It's not going to happen.
That is a disaster. Do not do that. Leave that to biology, and don't tell the professor I said that. Since we now have the internet, actually you can go on and search for free resources for physics course. Like there are, MIT put out courses that might be a little too advanced. So do you not think of?
University of Boulder, Colorado, they put out a really good set of simulations and applets. I think we'll put the link to that. So like an example of one of these, it just works online, so anyone can use it. You don't need any special software or anything, but an example like that you could use for a first year physics course to learn about friction, this thing where you can build your own kind of roller coaster, kind of a track, and then adjust how much friction there is on it, place an object on it that has a certain mass. You can change its mass, see how the path changes. You can look at pull up a little graph that shows you how the kinetic and potential energies vary. So there's fun things like that kind of take you a step away from just the equations and really show you what the physics is that's going on behind that. I think it's kind of a fun way to explore.
Yeah, totally. Help you internalize the things that you already learned.
Yeah, and give yourself kind of like a visual to go with it as well. That might help jog your memory if you're studying that stuff later.
Yeah, and I think also just shout out to Crash Course, because I think they have a series on physics as well for like high school students. So it's not going to be as difficult as like MIT stuff.
Oh yeah, there's
like
different levels.
There are different levels out there. So we'll try to put links in the description below so you can have a look at it. And if anybody knows a good resource for studying physics, please put it in the comments below. That would be great for us to kind of share here in the video.
Yeah, and help people find good resources for stuff for sure.
Yeah. And so thank you so much for today, Anna.
Thank you, Pam. That was great. I really enjoyed this conversation.
And actually, let us know if you find this video helpful or if you want more tips for studying physics.
Yeah.
Because I think we can keep on talking.
We can always make a part 2.
We can always make a part 2, exactly. Okay, for now, See you.
Bye.